Well, hello there, everybody, and welcome to our continuation of notes on sets. You kind of have to think about sets. Learning sets is kind of like learning a foreign language because there's going to be different notation, and that's kind of like your accents that you have in different languages, and there's a lot of vocabulary. So we just got to kind of get through some of the vocabulary to go on and do operations with sets and things like that. So we think of a subset as part of our original set, and all of the elements of the subset must have been elements of the original set. The empty or null set is a set with no elements represented by the brackets or it kind of looks like a zero with a slash in it and brackets with nothing on the inside. If you get into higher level set theory, there's kind of a very fine distinguishing feature there, but we consider the empty set and the null set to be synonymous. So you can use either to represent a set that has no elements. Now, what is an example of that? Well, an example of that would be, let's say that you guys were here in the classroom with me. I would say, well, give me the set of all students in the room who are over the age of 18. Would anybody raise their hand? No. We don't have anybody in our class who's over the age of 18. So that would be an empty set. A finite set has a countable number of elements. So anything that ends, so to speak, that you can count up the number of elements. An example would be the number of students at Barker Road. We can count how many students there are at this school. An infinite set, on the other hand, has a non-ending, uncountable number of elements, and an example of that would be the positive numbers. They don't end, they go on, and so therefore they are infinite. Consider the set defined as 1, 2, 3. There are 8 subsets of set A, and they want you to list them all. In this example, we would call set A our given universe. So if we have a universe, we're going to take subsets of that universe, and those are going to be 1, 2, and you should be writing this down, 3, 1 and 2, 2 and 3, 1 and 3. That gives us 6. There are 2 more sets. One of them you might be thinking of, and it's a little abstract, and that is the empty set or the null set. That is a subset of our given set. But what is that last 8th set? That is called an improper subset, and it's a subset containing all of the elements of the original set. So we're saying that 1, 2, 3 is a subset of 1, 2, 3. It kind of seems redundant, but it is considered a subset, albeit an improper subset. Okay? Now we're going to talk about the complement. The complement is all of the elements that are not in our given subset, but are in the universe. So if you look at our given subset of 1, the complement of that set would be 2 and 3. If I said, what's the complement of set 2 there? It would be 1 and 3. Okay, the notation is either whatever the given set is. If it's S, then it would be S prime, S with that little line over the top, or tilde S. So let's do some examples here so you can see how this works. Consider the set E defined as 2, 3, 5, 7, 11, and 13, and set F is defined as 2, 5, and 7. The complement of set F within our universe of E is going to be F prime, and we're going to list the elements that are in set E that are not contained in subset F, and that is 3, 11, and 13. Make sense? So if I consider the set of integers as my given universe, the complement of the set of whole numbers, you should be thinking about what this would be in roster form, so that's like our curly brackets. Okay, let's call it F prime again, is going to be the numbers from negative infinity up to and including -1. We can't go to 0, obviously, because 0 is a whole number, and we wouldn't want to list anything in between those because we're just concerned about integers here. Example 3. Given the set of numbers on a 6-sided die, which of the following represents the complement of the set comprised of all multiples of 3? So you can be thinking about this. Okay, and if we look at our examples, we wouldn't be able to have any multiple of 3 in there. So therefore, we would have to say the answer is, oops. Oh yeah, it's D. That's right. Okay. Um, Example 4, and here I'd like you to read it and try to think on your own of how you're going to write these before you come back and get the answers, okay? So you should kind of pause here and think about if you knew how to write this. Suppose the universe in each of the following is a set of reals. State the complement of each set that's given using set builder notation. Set builder notation is what you see in front of you. So you're going to write something similar to that notation. Okay, so why don't you pause here and try to think about that. In example A prime is going to be, if I'm considering the reals anything above and including 4, the complement of that is anything that's below 4, less than 4, not including 4. And how do I write that? X such that X is less than 4. And I wouldn't want to use the line because I wouldn't want it to include that. B is the set of all reals less than -3. So the complement would be all reals greater than or equal to -3. And if you think about C, X is less than or equal to -4 or greater than or equal to 4, then my complement is going to be all of those numbers between -4 and 4, not including -4 or 4. We'll get to how we refer to that in a couple minutes. I have a little bit of a cold here, so excuse me if I'm kind of gurgling on the other end. Okay, interval notation. This represents intervals on a number line without using the number line. I think you're going to, this is very easy. You're going to like this one. Interval notation is easy. These square brackets we call hard brackets, and they're used in place of your filled in circles, your closed circles, and it means that we include that number. The open brackets, parentheses, soft brackets, those are all synonymous. So open brackets, soft brackets, parentheses are used for open circles. We do not include that given number. So for expressing the interval x is greater than -3 and less than or equal to 2, we would use the soft bracket by the 3, the -3, and the hard bracket by the 2. So let's do a couple of examples here. I'm not going to do all these. I'm going to pick a couple of them. I want you to not do number 10, or I don't know if that's number 10. I don't know what it is. But don't do the last example. I'm going to do a couple of them, and then you're going to finish this page. So let's take a look, for example, at the first one. Okay? Now, what I have there is I want to include the -6. So therefore, I am going to put a hard bracket at -6, and it's an open circle at 8. So I want to exclude the 8. Set builder notation is a little bit more cumbersome. So I'm going to say that's all numbers x such that x is an element of the reals. Okay, and x is greater than or equal to, sorry, I kind of squished this in here, -6 and less than 8 in my curly bracket again. So that's kind of a little bit messy, but I think you can get the idea there. Let me go down and do another example for you. Let's take number 4. Okay, we'll do the set builder first in this case. So I'm going to have, you're kind of talking about it. You're saying I want all numbers x such that, that line stands for such that, x is an element of the reals, okay, and x is going to be greater than -2, and that's all I care about. Oops. X, oops, I lost my pen now. X is greater than -2. That's all I care about, right? Because I want to go on and on. Now, in interval notation, what that's going to look like is go back and put that or equal to under the -2. I'm wrong there. It's greater than or equal to. See that filled in circle? So that's going to mean I need a hard bracket at -2. And I go on and on and on and never end, which means I have an infinity there. And since we don't know where it ends, infinities always have a soft bracket. Okay? And I'm going to let you guys do the rest of those with the exception of the last one. You can just skip it. We will talk about it tomorrow, so please don't exit out or cross it out or otherwise make it so that you're not going to be able to see it. All right, little comment at the top there. Do not confuse interval notation with a coordinate point. You have to consider the context. Like anything else, am I talking about sets or am I talking about the coordinate plane? Parentheses are used in different circumstances with different meanings. So be careful not to be confusing in the first example. The set, and they're obviously talking about sets here. I'm not talking about the point -3, 7. I'm talking about the interval -3 to 7. Okay, so if I'm looking, for instance, this is not the answer, but let's just say I'm looking at this particular notation. It's saying I want to go from -3 to 7, not including -3 and not including 7. Okay? All right. So which of the following would be the answer to this? I want to exclude 3, include 7, so it would be here. Okay? And then the next one, be thinking about your answer. We want to, we actually have to solve this. Okay? So if I need to solve that, you guys can be doing this on your own and come back to me when you're done. Remember that you get -2x is greater than or equal to 10. Dividing through by a negative number causes us to flip the inequality. I get x is less than or equal to -5 or equal to gives me the hard bracket. Okay, and then infinity is always an open bracket, so that would be A. A few little extra terms here. Okay, and this is what I was referring to earlier. Inclusive is closed, so it's saying like I'm including those endpoints. Exclusive is open, excluding those endpoints. And then obviously half closed, half open. Okay, so inclusive is saying I want to include -8 and 4, which is going to mean hard brackets. So hard brackets is going to give me which option there? What do you think? It's going to be D. Okay, I don't have a pen, but D. All right. Which of the following intervals half closed? You have to look at your options. The only one that has mixed symbols is C. Suppose the universe of the following is the set of real numbers. Graph the complement. This isn't too bad. I'll do one example and then I'll let you guys do the rest for homework because I think you'll be fine with this. So I'm looking at example A and I want to graph the complement. Well, if this includes -1 and above, I have to exclude -1 and go below. Okay, so you guys can go ahead and do B and C and do those other problems on this page that we didn't do with the exception of the last one. All right, have a great night, guys, and I will see you tomorrow.